Okay, let's move on to the next scenario. What if we get data from multiple sources, just like the country example we have seen previously, but we get bits and pieces from each of these sources and we have to combine them into one big data frame. For example, say you're trying to do some analysis in Amazon, maybe some analysis related to orders, customer orders. So you're the data scientist or an analyst and you want to get order data. So what do? You go to the Amazon engineer, the software engineer responsible for maintaining the website, and say, I need order data, maybe for a particular date range or maybe for a particular country. And he's going to give it to you, maybe not in the format that you want. For example, typical backend systems store order in multiple tables. For example, this could be an order header. So this is order header, meaning this is going to be an order number, and then let's say order value, and then we're going to have an order details table that's going to have order number, line number, then the material that has been ordered, the product, so on and so forth. Just to give you an example, let's say this is order number 1001, okay, and the order value is say $90, okay, and then here is order number 1002 and this is $103, okay. Now this only gives order data that's at the header level, right, meaning the overall summary. In this table we're going to have order number 1001, the first item, right, and what's that product? Let's say it's a toy. And 1001, the same order, there is another line, and this time it's a bag. And moving on to the next order, 1002, line number 1, let's say this is some coffee, and 1002, line number 2, this is some almonds. Now, our intention is to have, typically data frames for analysis tend to be very flat because you can't do much of an analysis with this kind of a structure. So you tend to flatten your data like so. So order number, order value, line number, material, so on and so forth. And the way we're going to structure this data, when you flatten it out, it's going to look like this: 1001, order value 90, line number 1, toy, 1001, same order, line number 2, it's a bag, 1003, 2, this is 103, right? So this way we can do better analysis. Now, how do you merge data frames that don't have a similar column structure, but they have something very useful, which is the order number. It's called as a primary key, but think of it as just a common field. Order number, order number. That's the common. Sometimes there are 2 common fields or 3 common fields, but in this case we just have 1 common field, order number. And based on this common field, we want R to merge these 2 data frames into a single data frame that's flat, that has all the data from data frame 1 and data frame 2. How do you do that? To do this, we use the command called merge. And merge is a pretty smart command. There's a whole lot that's going on under the hood. We're going to see some examples. We're not going to see all the possible cases, but we'll see some of the examples of what merge can do. And in order to do that, so here is our data: orders, orders contain the order number and not the order value but order status, and order details contain the order number, line item, the product that's being brought, and at what price. Now in order to do this analysis we need these data frames, right? So I have attached comma separated files here, just some samples, nothing big. Just download them. We have our order.csv and order details.csv. Okay, go there, show in folder, and go there, copy them, go to the R, and orders equals read.csv of /.csv. And before we execute this, we just have to make sure that we do escape the backslashes, or you can use forward slashes, but since we are on Windows, let's just do backslash, enter. So orders is created as a data frame from the CSV. Now same thing with order details, order underscore details, and we're going to say order dot details or order underscore details, and there we go. So we got both these tables created as two separate data frames. Now remember, we want to merge these two data frames together. Now how should the merged data frame look like? It should be a flat structure that's going to contain data from both the data frames. The way we're going to do that is by saying merge of data frame 1 and data frame 2, right? Merge of orders and order detail. Okay. Oh, it's not detail, it's details. There we go. So here is our data structure, the combined data frame that has data from both the orders and order details table. In case you're wondering how the structure is looking like, so there we go. So here is the order number and order status, and for each of these rows, as many rows as there are common in the data frame 2 will be added here. For example, if you look at the data frame 1, it has one order row for 13,001 and then 2 line items, right? So the final data structure should have 2 line items that combines one of these header against 2 of these line items. So the final data structure is going to have 2 lines that are flat, and it's going to have some redundant information, but that's okay. For example, this is redundant, but that's how a flat data frame looks like. It contains a lot of redundant information, and that's primarily the reason why originally the data was stored as 2 separate tables, because of all this redundancy. But when we want to do analysis, we want to combine all of them together. We want uniformity. We don't care about redundancy. So there's a whole lot of repetition here, right? So there's 3 rows for 13002 because there are 3 line items in that order, and then 4 rows for 13004, 3 rows for 13006, order numbers. But that's how we want to combine, and that's what merge command has done. Now the next question is, what happens if the column name was different? Well, the data is the same, but let's say the column name is different. For example, in the order details table, instead of order underscore NO, we're going to say order underscore number, right? So we're going to change this to order underscore number for the order details table. Order details of 1 is order number. Okay, you see the change? Order number is now changed to order underscore number, but The other table, orders, is still order underscore NO. Now, we are trying to combine order details with orders data structure. Now, I'm just giving you the first two rows so that you can easily see. So we are trying to combine this data frame and this data frame together. Well, R can do it, but how does it know that this order number, order underscore number, and order underscore number represent the same columns, and the merge should happen based on these two columns? Well, you could do something like, change the column name, but in a data pipeline, you might not have a chance to do it, or you might not want to do it for a variety of other reasons. So is there a way we can combine these two data frames together using this common column, order number, although the column names are different? It's just that the names are different. The data is the same. Data represents the same thing. So let's actually do something. Let's try and combine this as is and see what happens. Right? So let's do a merge of order details and orders and see what happens. Whoa, this is 90 rows. Why is that? Why does it have 90 rows? Let's start all the way from the beginning. So there's 13,001, and we know that there are two line items. And then there is a 13,001 here again. Why is that? Because R didn't know that these two columns are the same. So what it has computed is what is called as a Cartesian product. Let me explain that with an example, a very simple example. Let's say we have two data frames. Okay, and these are two different columns, meaning this is, let's say, the country, India, US, and this is, let's say, the population, and this is 1.5 billion, and this is, let's say, 300 million. And column 3 is something else. Let's say this represents the number of cars, per capita number of cars. India is going to be like 30 cars per capita, and US is going to be like 1,000 cars per capita. And this is, let's say, and this is the GDP, and this is like 15 trillion, and this is 2 trillion. Okay, what is meant by a Cartesian product? Cartesian product. Cartesian product basically gives you all possible combinations. So it has 4 rows, again a very flat structure, which is good. So there's 1, 2, 3, 4, and this is going to be country, number of cars, GDP. And since there's no common column, it says country, India, population 1.5 billion, a number of cars 30, GDP 15 trillion. Okay, now this is where it gets really nasty. The second row says country, India, 1.5 billion, and it pulls in this data and says 1,000, 2 trillion. You see, that's not correct. But that's how a Cartesian product works. It's everything against everything. And then you're going to have US, third row, 300 million, 30, 15 trillion. This row it got from here, which is not even related to the US, right? So essentially, Cartesian product is not useful in most of the cases. It's a very rare case where Cartesian product is used. And when there is no column that's common between these two data frames, 1 and 2, and you try to merge these two data frames, you're essentially forcing R to create a Cartesian product. Alright, so we know that that's not what we want. So instead, what we're going to do is, we're going to do something like this. We're going to specify that this is the column that we want to merge with or merge by. So, so we're going to be saying merge order dot details and orders data frame by dot x equals order underscore number, by dot y equals order underscore number. Now let me just do it and then explain what I mean by the by dot x and by dot y. So if you look at head of order details, and well, we know that in this column are the same thing, but they're named differently. So the way we're going to tell R that these two columns are the same is by specifying this as data frame 1, this as data frame 2, right? And then when you say by dot x, you're referring to the first data frame's column, order underscore number, right? The order table has an order underscore number, and by dot y refers to the second data frame. The second data frame, orders, has order underscore number, and that's what we want R to focus on. So this is essentially a way of specifying what are the common columns between these two data frames. Use those columns to merge this data together. Now let's see if the data that we get is correct. Okay, let's get the first 10 rows. This seems okay, isn't it? It has just 2 rows for 13,001, just 3 rows for 13,002. So unlike the previous case of Cartesian join where there were like 6 rows just for one order, unnecessary rows, this time it's got it right. And then there's no this additional order underscore no column. There's just one order number column because R has understood that that is the column that it needs to merge, even though the column names are different. Now, if this is confusing, don't worry. This is not done a lot of times. You just probably go change the name of the column and then be done with that merge. But in case you're not able to change the column, you can specify what columns to merge by using the by.x and by.y command, or by.x and by.y options.